So another case study is the impending wildfires that have happened as a consequence of these heating areas. So let's take a look at Alaska. In June of 2015, we found that over 300 wildfires were burning in Alaska. And you can see the smoke here. This is a satellite photo. And here you can see, look at all this smoke that's coming out through here. It's just all coming through here. This is all smoke. And a lot of it ends up going into the Arctic. So this smoke is going to have an effect on the albedo, or the reflectivity, of any ice that it settles upon. So these wildfires cause albedo changes in the Arctic, as I just mentioned. And we find that high temperature rises are starting wildfires all over the northern hemisphere. I mean, now in the western United States, we have fires going in Northern California, Oregon, Washington, Idaho, on and on and on. All of these, Montana, all of these places have huge fires going on, and they are also dry. All of these fires send a huge amount of greenhouse gas and soot into the air, which have effects. Some of these fires are huge. Would you please take a look at this? This is a tundra fire up in Alaska, and these tundra fires are just so strong, and they're hard to put out as well because there's a lot of combustible material that goes very deep. These tundra fires add volumes and volumes of CO2 to the atmosphere, and a lot of this soot settles on the poor Arctic. All of this is melting our Arctic ice cap. So let's dive into the science now and see what's up. So this particular graph is plotting the sea ice extent between globally, kind of the average, right? The Arctic and the Antarctic. Look at the Arctic sea ice extent that's currently on. You can see how steep in decline it is. Globally, the sea ice extent is going down as well, but if you, and the Antarctic, that's kind of yearly ice. It's going up slightly, but we'll talk about that. The Arctic is really where the action is, and look at how much the Arctic sea ice extent is just dropping before our eyes. Now, it's changed a lot, actually. If you look at this map between 1980 and 2007, that's 27 years. Look what's happened. 2007, admittedly, was a low sea ice, but we're getting there again. There's a huge difference. Anyone can see that the sea ice is just dwindling before our eyes. And the reason it's dwindling before our eyes is it's so extraordinarily hot. We have seen extreme global sea surface temperature anomalies in the Arctic, and I want to take us back to last year in September, which is the low sea ice extent for that time in the Arctic, and take a look at this. You will notice, if you look at the Arctic above Greenland, that the Arctic is red hot. In fact, it shouldn't be bright red, it should be chillin', but it's not. I mean, it's really hot, and heat melts ice. There's just, that's chemistry. So let's talk about the Arctic heating up, and it's heating up twice as fast as the rest of the planet. If you take a look at this, kind of turn your head to the right, and you'll see the 90, mostly on the right-hand side. That's the North Pole, and the 90 on the left-hand side is the South Pole. So you'll see the Arctic is really heating up twice as fast as the rest of the planet. There's no question about this. We'll talk about this little dip over by Antarctica that has to do with additional seawater and cold water going in to the ocean, taking that down. All right, let's talk about the changes in the Arctic that are driving the changes we are seeing elsewhere on the planet. So the disappearance of the ice in the Arctic is actually leading to warmer air masses moving over Greenland in the summertime. That's causing the Greenland ice sheet to melt much faster, and that also is causing global sea level rise to elevate. In short, our Arctic is dying, and at some point in the future, and I do not know where that will be, I don't dare to speculate, but we will have a time when we do not have ice in the summer in September in the Arctic, and it won't be very many years in the future, but I'm not going to make some prediction because I really don't know. But what we do know is that the Arctic is in a death spiral and that ice is quickly going away. Now, when that ice goes away, there are a lot of other things that are connected to the Arctic. So the Arctic, if you want to say the Arctic is a domino, that thing has tipped. It's done. It's just a matter of time before it melts. But the Arctic affects the Greenland ice sheet. The Arctic affects the peatlands. The Arctic affects the boreal forests. And most importantly, the Arctic affects the permafrost and the runaway greenhouse gas emissions that come out of the permafrost. Let's go ahead and take a look at this. Additionally, please see the work of Lester Brown. He's the former head of Earth Policy Institute, a real warrior on the global warming and Earth policy front, just a gem of a man. This is how the sea ice extent looked as of a couple of days in the Arctic. You can see there's kind of, this will definitely go away. And as well, there's going to be a lot of pulling back in here. So this is more or less kind of how it's looking at this point in the Arctic as of August 25th. Let's take a look at from the top of the world. This is more or less the skull cap of the Earth. And what we can see here, just to give you a reference point, Greenland is here. The Canadian archipelago is here. Alaska is here. Siberia and Norway. Svalbard's here. So you can see the Arctic is hot. It's much hotter than it should be, and you shouldn't see any redness in the Arctic, but we are seeing the Arctic becoming hot, and it's becoming warmer in the Arctic than at any time in the last 110,000 years. Think about that for a minute. It's kind of stunning. So what we see time after time is we have underestimated the consequences. So this from the IPCC model. According to the IPCC, which is the Intergovernmental Panel on Climate Change, which was founded by the UN and other agencies, the Arctic sea ice was going to last us well into the 22nd century. You can see that they don't have it melting out there, you know, in 2100 at all yet. You know, they've got two standard lines of deviation, which you see on either side of the line. But that's not really what's happening. In fact, the observations are completely different from the modeling. So clearly, the model is not correct and is far too conservative. So let's dive into the Arctic at this point and take a look what's happening in the Arctic and how waves and storms affect sea ice in particular. So take a look. This is the Arctic, March 9th, 2015. And we're going to do a drill down on sea ice thickness. To give you an orientation, this black ice here along Greenland is the thickest ice. Then this green ice is the next thickest, the third thickest. The very lavender and dark blue ice is very thin. So this is how we started the melting season. What we found on March 12th, a very unusual event ensued. We had 7 different storms happening at the same time. We had Pam down here by New Zealand and, well, actually by the Solomon Islands. You can see Pam here. There were a few other storms. There were several storms up here in the Arctic as well. And they created high winds and high waves, and they started to batter away at the Arctic sea ice. So March 13th, 2015, we find ourselves in sort of a gale situation in the Arctic. And waves as high as 41 feet high were recorded right up here by Norway. Can you believe that? And these were battering against the ice in the Arctic. How would these 7-meter high waves that got right next to the ice, how much would they have destroyed, you know, the ice that's just struggling to stay intact? Quite a bit, I would say. Let's talk a little bit about rivers as well. This is another feedback that heats up the Arctic and contributes to the demise of the Arctic. So we're going to talk about baked Alaska again, 2015 in May. And we can see here in May of 2015, here's the Mackenzie River running right along here. And see, it's here, it comes right out into the Beaufort Sea. And what happened is when Alaska got very, very hot, it melted all the snow, such as it was, and it all flowed, hot water, into the Mackenzie River. As well, rivers in Siberia flowed into the Arctic Ocean as well. So take a look at this. You'll find that we've got here, this is the Lena River right here that goes between Lake Baikal and the Arctic Ocean and the Laptev Sea. That's a huge area of hot water that goes in. As well, we can see these other Siberian rivers that are over here by the Kara Sea, as well as rivers over by the East Siberian Sea. All of these rivers, with all of the heat waves that have been going on this last summer, filled up with hot water, and they put themselves directly into the Arctic Ocean. You can see, this is a salinity map. Isn't it interesting? It's beautiful as well, isn't it? But when you know what the story it's telling, it's shocking, because take a look at this. Here's where the Mackenzie River is coming out right here, and look right there, boom, that's the plume of non-salty fresh water. This is a salinity map. You'll also see, look at all this is practically all fresh water along the Laptev Sea in Siberia. It's very interesting. As well, you might not have been aware, but the Atlantic Sea is extremely salty just by nature, as there's a lot of evaporation, and the Pacific Ocean is not as salty as the Atlantic Ocean, but the Arctic Ocean is freshest of all. In fact, the Arctic Ocean is almost fresh with all the water that's going in from the rivers. So hot rivers contribute to sea ice decline, and that's exactly what we see happening here in the Arctic Ocean. Here on this particular map, it's interesting. This is just a couple of days apart, 9 days apart, May 9th and May 18th. Look at this ruffling right here. You can see this is the Lena River coming out in Siberia and just melting with its hot water all the way up to the North Pole. The Lena River is melting the Arctic sea ice strongly. Let's take a look a little bit further down into the summer, this animation from May 6th to June 4th, and you can see that the sea ice thickness is just dwindling away. It's just looking so weak, and you can also see there's water coming in here between Alaska and Siberia in the Beaufort, and you can also see that all of these rivers are having an impact on the sea ice thickness. And you can see the plume too coming out. Watch this right there. Did you see that plume? It came out from the Lena River straight to the North Pole. It's interesting how these systems work, isn't it? So a little bit further on in the summer, this map from July 5th, we can see the sea ice thickness is in steep decline. In fact, you can hardly see any of that green ice that we had a little bit further. So let's watch that green ice kind of slip away. It's just starting to go away because the ice is not as thick as it used to be. Now, this is fascinating. Take a look at this. These are 4 maps from 2012 to 2015, and this is the sea ice thickness compared across July 15th for 4 years. Take a look at July 15th, 2015, the last picture in this series. You'll see the sea ice is practically nothing compared to where it used to be. In fact, commenting on this picture, Harold Hensel, an eminent student of methane and climate science and a kind of a climate generalist himself, says, I look at these images and have about the same response as the NASA control room when the Challenger blew up. It was dead silence. Why would Harold Hensel, an eminent person of science, say such an inflammatory thing? Why would he say that? Well, he'd say that because he can see by looking at the sea ice thickness that soon our sea ice thickness will be gone. And if the sea ice thickness is gone, we do not have ice in the sea. So let's take a look at the Gulf Stream. The Gulf Stream is very instrumental in moving hot water up to the Arctic. So here's the Gulf Stream picture. You can actually see it. This is a temperature map of the ocean, just still temperatures. You can see all this over in Florida. My goodness, look at how hot it is there over in Florida. But here's the Gulf Stream right here. And this moves up and deposits its warm water into the Arctic Ocean. Just another comment about Florida, you'll see that the sea surface temperature was about 92 degrees on this particular day. That's pretty darn stunning. Take a look at this ocean current map. Very interesting. Again, we can see here's the hot water from the Gulf Stream. It goes up, kisses the side of England, and goes on its way, kind of splitting itself between Svalbard and Greenland and kind of making its way about. Now what's interesting is when this Gulf Stream current, which travels under the surface of the water, it doesn't travel on the surface of the water, but it makes surface. It basically goes, and when it hits Svalbard, it comes to some shallow water as the island starts coming up, and it hits Svalbard and it comes to the surface. And you can see where the Gulf Stream is crashing into Svalbard here and here. It's actually creating a huge sea surface anomaly that's creating a lot of changes in Svalbard, as you can imagine. Here's another picture a few days later. You can see, in fact, this is August 25th, just a couple of days ago, and you can see that Svalbard is on fire. It was 63 degrees in the water beside Svalbard on August 25th, just a couple of days ago. This is a 21 degree Fahrenheit or 12 degrees centigrade anomaly. To think of this is really stunning. This is the Arctic death spiral updated for 2015. You can see that there was a recovery between after 2012, which we had the lowest, a very low sea ice extent, 2013 and 2014, the Arctic sea ice recovered a little bit. In 2015, I think it's going to be lower than 2013 and 14. I don't think it's going to be the lowest on record, but I think our little 2-year recovery is over. That's my assessment at this point. And the reason I'm saying that is take a look at the sea ice extent map. You can see right here we have fallen out of 2 standard deviations. The dotted line is 2012. This little blue solid line is how far we've gotten thus far in 2015. We are 2 standard deviations outside of the model, which means that we're outside of the realm of possibility for modeling. So with that, we're going to take a deep dive into Arctic sea surface temperature anomalies. This is super, super fascinating, I guarantee it. And in particular, before we dive in, we're going to take a look at how the sea was when it was high, before the melting started. And we're going to take a look, please pay attention to these areas here in the Kara Sea, where you have all these little rivers coming out. And then likewise over here in the Laptev Sea, and this is the Lena River. Please watch this area. as well watch this area, the Mackenzie River, as well watch this area. And also watch the area where Svalbard is, because this is high sea surface temperature anomaly due to the Gulf Stream current, as well watch this area in the Beaufort by Alaska and Siberia. So keep your eye on all of these areas because they are all being, quote, attacked by heat in, as you shall see. So going first to May 27th, kind of the beginning of our melting season, we can see some initial anomalies happening on Svalbard and so forth. Going in a couple of months later, July 20th of this year, 2015, we can see degradation happening and melting happening here in the Kara Sea, starting melting here in the Laptev Sea with the Lena River, and starting some severe melting here by Siberia and Alaska in the Beaufort Sea, and in the Mackenzie River area, as well as in Greenland. We can see that the melting is underway. And if we progress forward to August 2nd, we can see the melting is getting even stronger. And if we progress to August 15th, we can see the melting is getting even stronger. Look at this. This brown here is actually the highest on the temperature anomaly map. So we can see that this is over 5 degrees of where it should be, you know, centigrade, which is huge, right? And it's huge in here. And then look here, it's melting where the Mackenzie River is coming in, the Beaufort, the Lena River, and in the Kara Sea, it's melting. And then progressing forward to August 28th, we can see the melting setting in a little bit more. We think that the Arctic is going to look something like this when all is said and done in a couple of weeks, but you know, time will tell, but this is their guess of how it's going to stack up for this year. As well as sea thickness and temperature, there's another thing that we like to look at, and it's ice concentration. So that has to do with how strong the ice is, if it has water in it, if it has bubbles in it, if it has cracks in it, if it's totally strong. So this is the ice concentration animation, and you can see that the ice concentration is literally dwindling. This is a 1-month animation between June 28th and July 27th, and you can see that the Arctic ice is being impacted all around. I mean, it's being attacked from all sides, and the Arctic ice concentration is getting lighter and lighter and lighter. Now, this is a really kind of interesting map, and this is 3 types of measurements superimposed on each other. This is the Arctic looking straight down. You can see Greenland over on the lower right. This is wind, mean sea level pressure, and jet stream, all superimposed upon each other. This was July 31st in the middle of the Arctic Ocean. Clearly, it's not good when we have a cyclone in the Arctic Ocean, because it could possibly break up already very weak, thin, cracked ice. And in fact, it does. So we did have a little bit of a cyclone in the Arctic Ocean on July 31st. And that, you know, just adds to the sea ice demise and ice loss. So eventually, all this ice is going to melt and go away. I mean, it's a matter of time. It's being beaten up, it's being heated, it's being, you know, pressurized, it's being blown. All sorts of things are happening to this ice. And ice loss means that more sunlight actually gets absorbed into the sea instead of being reflected back into space. What could that mean? Well, obviously, sea is darker, so it's going to absorb a lot more energy than white. You know how it is when you go out on a hot day. If you put on a white outfit rather than an outfit that is black, you're going to be a lot cooler than you would have been otherwise. Same as with the Arctic. So sunlight that previously went into melting the sea and the ice, as well as sunlight that was previously reflected back into space, is now being absorbed by the Arctic Ocean instead. This is huge. This means that, you know, we're already kind of on the brink with all of our carbon dioxide emissions, but now, you know, it's kind of the chicken's coming home to roost. And we are finding that the Arctic Ocean is absorbing a lot of heat. So says Peter Wadhams, head of the Polar Physics Department, University of Cambridge. He has studied the Arctic ice for over 45 years.